Next one is the talk of Christina. Well, Christina is a member of the Brain Products family, and she's a strategic product manager. She joined the company as a scientific consultant in the marketing department back in 2017. And her main focus was on increasing Brain Products' efforts to foster the MoBI application field. Looking also at this event, I must say she has been also very helpful in this sense. Before joining Brain Products, she was a clinical research project coordinator at the Hospital for Sick Children in Toronto, and completed her Ph.D. in experimental psychology at the Karl von Ossietzky University in Oldenburg, in Germany, where she investigated inhibitory processes via combined EEG and fMRI. Sorry, just went too far. Christina, when you're ready, you can start with your presentation.
Okay, do you guys see my screen yet?
We do.
We do.
Do you see it?
Yes, we do.
Yeah.
Okay. And do you hear me? I guess so.
All good.
Okay, first of all, thank you for the really nice introduction, Piero.
Very welcome.
Just organize myself here. And thanks to everybody for attending the third installation of our MoBI Award ceremony. This year, it's actually looking quite a bit different than we had originally planned, but we're still really happy to be able to do this online. I see many attendees who are already familiar with the MoBI Award itself. We have former submittees, previous year's winners, and some of the judges. And I just wanted to take this moment and say that without our esteemed panel of jury members, none of this would be possible. So thank you to them for their time and efforts, not only this year, but over the previous years. Today, I'm going to give a quick 10-minute presentation on brain product solutions for MoBI research. Before I start talking to you today about our solutions for mobile EEG, let me just first briefly show a few examples of how and where our products have been used outside of the lab. We've been everywhere from bungee jumping, zero gravity, and mountain biking. We've also been underwater, in the cockpit of planes, skydiving, in orchestras, and at Everest Base Camp. Of course, these are not the standard use cases, but they highlight some of our more extreme EEG examples. As you saw from the previous cases, our goal is to provide you, the researcher, with end-to-end solutions for your needs, whether that be EEG in zero gravity or cycling around a university campus, like our last year winner, Joanna, who actually did not ask a question. In this case, we want to be there with you on every step of your journey, from research question to publication. This usually begins with a talk with one of us or our distributors at a conference or some other scientific event. For those of you who are already using Brain Products equipment, some of this may look very familiar to you already, but let's take a walk through what an end-to-end solution might look like for the MoBI researcher. And then I'll go into a bit more detail for each of the pieces. We can start off with our small minimalistic amplifier known as our live amp, which can be extended to include other physiological sensors and multimodal integration. We have a diverse range of electrode options, the active ones of which become especially relevant when freely moving. To complete your hardware solution, we also have software for recording your EEG, including video, as well as comprehensive and easy to learn analysis software. Now that you've got the overall picture, let's take a closer look. The live amp is wireless, compact, portable, and completely modular, meaning it can be used for recording 8, 16, 32, and 64 channels. Now, this was the prize given to our 3 MoBI winners today that you're going to hear speak. It's also compatible with our wide range of electrode types. Today, I will show the 2 types that are typically most relevant for a mobile setup. If you already have a live amp 32, it can easily be upgraded to a live amp 64 to obtain high-density EEG. The LiveAmp 64 is not only the perfect solution for high density and portable EEG outside of the lab, it also provides the added benefit of having two fully functional 32-channel amplifiers. This ingenuity, along with LSL integration, allows for hyperscanning, that is, recording two subjects from each LiveAmp 32. So you can see that you have quite some flexibility in terms of your recordings, whether you're streaming your data or storing it on the SD card. Additionally, the lightweight and compactness of this amplifier are especially useful for participants in motion. One thing we found that researchers, especially in the MoBI field, need is a high level of integration. MoBI researchers must typically integrate more recording modalities such as those from eye tracking, motion detection, video, and others. Movement parameters are often important for MoBI research, thus the LiveAmp comes integrated with a 3-axis accelerometer. Furthermore, with the sensor and trigger extension kit, as you can see on the top right-hand corner, we can record other physiological channels as well. For those doing exercise science, you can record other physiological signals. And for example, those doing sleep research, you can also record things like airflow out of the nasal passages. And these can all be integrated for simultaneous recording with EEG. Now, not only is movement tracking important, but typically also eye tracking. Therefore, we have full integration with Tobii eye tracking glasses with the LiveAmp. There is already one input trigger jack available on the LiveAmp, so the sensor trigger extension would add an additional 8 lines of trigger to this one input jack. Not only is the hardware integration easy, but we also have a solution for this in our analysis software as well. Now that we know about the modularity of the LiveAmp and how easy it is to integrate additional signals, let's talk about how to do fully mobile triggering. The wireless trigger, which you see here, consists of two parts, the transmitter and the receiver. The transmitter is plugged into the parallel port of your stimulus PC, or actually even better and easier is into the trigger box, which you see here on the right side of the image. The receiver is connected to the LiveAmp sensor trigger extension and replaces the original trigger cable. You can send 8-bit event markers from your stimulus presentation software wirelessly to the EEG amplifier. So this little device, comprised of transmitter and receiver, reduces additional cables associated with wired hardware triggering. Now that we've talked about the amp, the extensions for integration, as well as triggering, let's talk about the electrodes. So I first basically want to focus on the ActiCap Slim electrodes, and you saw some of these actually in Klaus's slides. The active electrodes, especially these which have a very slim, sleek profile, are the perfect match for mobile research, as they provide the highest signal quality. This is especially critical for applications where the participants are freely moving. The slim profile lowers the point of gravity and minimizes motion artifacts, as well as maximizes comfort. So this is comfortable and very good for subjects in motion. And one of the really cool features about the ActiCap is the live impedance feedback that's given on the LEDs at each electrode point. Here, you can set your thresholds in the recording software for when you're doing your impedance check to determine if they are within your accepted range of impedance. So red means the impedance is too high, yellow means it's eventually getting better, and green is within your accepted defined range. On the cap that you see here, the electrodes are lit up red, which means you need to continue working on lowering your impedances. And such a live feedback is especially useful when you and your participant are not directly in front of your recording PC, as may be the case when you're a MoBI researcher. What you're seeing here are the traditional passive AGCL gel-based electrodes, which some researchers still prefer. In James's slides, you actually saw his setup, which uses the live cap as well. What I want to point out here is the live cap, that is the fabric cap, which is holding the electrodes. There's a little pocket on the back of the cap to hold the LiveAmp. So this is perfect for keeping the cable short and minimizing movement-related artifacts from cable sway when your participants are in motion. Just so you know, all of our electrode caps can be customized based on your specific research needs. So that is, maybe you need a drop-down electrode to record EOG, or you prefer a different montage for whatever reason. Together with our partners at EasyCap, we can custom build the perfect solution for you. about integration with other physiological signals, eye tracking. But if you're interested in recording activity from the brain with two different modalities in a mobile setup, then EEG and Fnears is your best option. This is accomplished with the live amp and active electrodes for best signal quality from your EEG data, along with the lightweight and wearable Fnears amplifier. As you can see in the picture on the right, EEG is performed with live amp. It's right there on her belt, on the hip, in combination with the Nyrex Near Sport system, which is worn on the back, almost like a backpack, as you can see. Both systems have compatible wireless data transmission protocols, and data trigger signals can be combined via LSL for synchronization. For this setup, we can provide customizable caps for EEG electrodes and optodes. If you take a look at the bottom image, you can see that we make it easy for you to combine both EEG electrodes according to the 1020 system with your desired Fnears montage. So you have both your electrodes and optodes in one cap. With all of our amplifiers, you're equipped with recording software for collecting your EEG data. And we also have EEG analysis software available, whereby you can do all of your pre-processing routines in a very easy to use and intuitive interface. In Analyzer, you can also do many advanced EEG analysis routines beyond ERP, including time frequency. Furthermore, you can easily export the data and work with it in another program of your choice, like, for example, EEG Lab. We also have LSL compatibility, which is great for the MoBI researchers in order to be able to synchronize your different data streams online. We are really active in the LSL community, and we have connectors for all of our amplifiers. We even have our own GitHub page where we provide all of the up-to-date connectors. We've also recently published a new LSL viewer for monitoring online LSL streams. It's available for free to download on our website. If you can take a look here at the screenshot of the Brain Vision LSL viewer. You can visualize up to 32 channel EEG and auxiliary channels simultaneously, as well as display FFTs of up to 4 channels. With this tool, you can select one regular stream, so for example, EEG, and any number of irregular streams, so for example, markers, response devices, etc. And one really interesting thing is that the LSL viewer can also be used with other LSL devices, so that means it's not limited to Brain Products devices only. And if you're not yet aware of our BCI Plus page, go ahead and check that out. Here you can visit our most recent blog post featuring this Brain Vision LSL viewer. We provide a complete data processing pipeline using LSL, from downloading and using the connector, viewing and recording the online LSL streams, as well as dealing with the files. This tutorial is perfect if you're looking to get started with LSL. At Brain Products, we want to have a positive impact on the field of neuroscience and especially support this new field of MoBI research. We presented the winners from the 2018 MoBI Award at the MoBI conference in Berlin in 2018. And although we're missing you guys this year in San Diego, we're happy to be with you here online today. The MoBI Award will be held biennially, so we invite you to consider already for applying for the next instance of the MoBI Award in 2022.